Welcome to the video on, is there a best classification algorithm? This video we're going to talk about this question, is there a best classification algorithm? It's a question you should know the answer to. The answer clearly is no. There is no one best classification algorithm, not one that's going to consistently perform best on every data set. One of these fundamental principles of data mining is that you need to understand your data so you can pick the algorithm that's best tailored to your data, maybe because the algorithm makes assumptions that are present in your data, Gaussian distributions, linear separation, types of variables, whether they're continuous or categorical, etc., dimensions of your data. But what we really want to look at is a very interesting paper, and the title of the paper is Do We Need Hundreds of Classifiers to Solve Real-World Classification Problems? What the authors do in this paper is they take a very broad set of classifiers. So they take 179 classification algorithms, implemented in a number of different software languages, Python, R, C, and they say these classification algorithms really come from 17 different families. And of course, they're listed here in the abstract to this paper. Discriminant analysis, Bayesian neural networks, support vector machines, decision trees, rule-based classifiers, boosting, bagging, stacking, random forest, and other ensembles, generalized linear models, nearest neighbors, partial least squares, and principal components regression, logistic and multinomial regression, multiple adaptive regression splines, and other methods. So the full suite of things that we've covered in this class, and some wide number of variants on those different things. And they're implemented in different software packages, Weka, R, C, and MATLAB. And then these classifiers are run on 121 different data sets, and they go on to talk about where those data sets come from. So there's a wide variety of different types of data here that they run these on. What they're looking for are trends for which algorithms tend to perform the best the most often, and that's a hard thing to qualify. So when you read this paper, and part of your assignment is going to be to take a look at this paper, how do you qualify those? And so the results of this test will be how you qualify this. They certainly pick right here that the classifiers that are likely to be best are the random forest. And that doesn't necessarily mean random forest are robustly the most accurate, of course, but they're generally an out-of-the-box, very good algorithm to use. This paper was, at the time this paper was published, I believe random forest tended to do top in the Kaggle competitions. There's been some gradient boosting algorithms that have been outperforming random forest more recently, and 10 years from now, there may be some other variant that's outproducing. Some of that may have to do with the software implementations and how quickly they can be used for training and testing and a number of different factors. When we look down below at the bottom of this paragraph, starting here, the random forest is clearly the best family of classifiers, 3 out of the best 5 classifiers in their test of random forest. Now this has to do with how their test criteria is computed, followed by support vector machines, which gave 4 support vector machines in the top 10, and then the top contenders on the sort of worth mentioning list, there's neural networks, boosting ensembles that were doing well as well. So as you read this paper, take a look at how they test things, and notice that even the top performing random forest has some data sets where it performs quite poorly on. I just really want you to enjoy this paper. You've earned it, taking the course and understanding these many different classifiers, understanding so much that's under the hood, and now you get to read a paper that goes through the full suite of things that you've learned. Enjoy. Thank you for watching.